Okay, so starting at the top, we're going to go over exponent rules. I'm assuming you've seen this in Algebra 1? Anybody seen this in Algebra 1, exponent rules? Okay, awesome. So it should be review, but again, if you don't use it often, you forget these exponent rules, but they do come in handy. So, for example, if you have x raised to the a times x raised to the b, you can just add those exponents, and some of you may have practiced that on Khan Academy, which is great, so this will feel a little bit easier. When you're dividing and you have the same variable, this exponent, you can just subtract those exponents to figure it out, and we'll practice this in a second. When you have a situation like this with a parentheses and an exponent outside, then you take this exponent and you multiply it by the other exponents here. If it doesn't have an exponent, that's considered like 1. So it would be like x raised to the 1, and you can just multiply 1 by that number. Then over here, and a variable raised to the 0 power equals 1. A variable raised to the negative exponent, or negative 1, would be 1 over a. Or if you had like a raised to the negative 3, that would be 1 over a to the third. So anytime you have that negative exponent, you just put it as a denominator. Yes?
Is any number to the power of 0, 1?
Yes. Okay. And then here, if you have 1 over a to the negative 1, that would just be like a to the 1 up to. Okay, so now we're going to get to some examples. We're going to be using the rules, but I'm also going to be talking about why the rules work, because it can be hard to remember whether you add or subtract, but if you understand why you're doing what you're doing, it can be easier to remember. So for number 1, we have m to the 5th power times m to the 3rd power, and based on our rules, we just add 5 plus 3 to get m to the 8th power, and that is our answer. But why does that rule work? Well, if you were to write this whole thing out, and just write, I'm not going to write out every one, but this first one, write it out. So m to the 5th power would be m times m times m times m times m, 5 m's, right? And then times m to the 3rd power would be times another 3 m's. So then we have a total of 1, 2, 3, 4, 5, 6, 7, 8 m's, so that would be m to the 8th power. And instead of writing it all out and figuring it out that way, we can just add those exponents. That's why it works. Neat. Okay, number 2. Gracias, thank you. Okay, number 2, now we have the exponent outside, and based on our rules, we just multiply those, so it would be y 7 times 3, which would be y to the 21st power, and that is our answer. The reason why it works, if you had y to the 7, or y listed out 7 times y to the 7 times y to the 7, there would be 21 7s, so that's why it's y to the 21st power. Okay, and number 3. So something to note is that when you have this like negative 3 power on the x, it is just applied to the x. It's not applied to the 4 as well. Unless there was like parentheses around the whole thing, it's just on the x. So when we rewrote this, this would go as a denominator, and you just rewrite it like this, 4 over x to the 3rd power, like this. And then you could solve if you knew what x was. Okay, number 4. We have a division problem with the exponents here. Now, based on the rule, we would just do x 7 minus 3 to get x to the 4th power, and that is our answer. Why does that work? Again, we're not writing out them all, but the reason why it works is if you had 7 x's, 4, 5, 1, 2, 3, 4, 5, 6, 7, over 3 of them, then you could cancel out x's. Okay.
Okay.
Can you guys be quiet?
I'm learning it.
Shh, quiet. Okay, we'll wait for you. Okay, anyways, so I wrote out x to the 7th power here, x times x, dude. Thanks. Okay, I wrote it out 7 times x to the 7th power here, and then x to the 3rd power down here. Now what happens is like your x's cancel, so you could cancel this one, this one, this one, and this one, this one, and this one, and you're just left with x to the 4th power. So if you forget the rules, if you understand the concept, you can still find the answer. And like you saw on the PSATs, this is something that is on the PSATs and SATs. Okay, so now it starts getting a little bit more complicated. We're just going to continue using the rules. For number 5, it has the exponent on the outside of these parentheses, so I have to apply this squared to everything in here individually. So I'm like, it's going to be -3 squared, and then it'll be 2 times 2, so x to the 4th power, and then y squared. So I'm just applying the squared to all those. And then for this one, y cubed, and that whole thing is cubed, so we multiply 3 times 3 to get y to the 9th power. And now I simplify if I can. So y squared times y to the 9th would just be 11y, so it's y to the 11th power, x to the 4th. -3 squared, that would be -3 times -3, which would be +9. And there's our simplified answer. Okay, continuing, numerous ace. Now we have a fraction, we have the squared outside. We need to distribute this squared to everything on the top and the bottom. So we're doing the same thing we did over in number 5, but now we're doing it everything top and bottom. So everything's getting squared. So it'll be 3 squared. This will be 3 times 2, so m to the 6th, n to the 10th power, over 2 squared. 5 times 2, m to the 10th, and n squared times 2 would be n to the 4th power. Okay, what next? We're going to take it one step at a time. We do need to simplify this m to the 6th and m to the 10th. That can simplify here, and so can this. So for the m's, we can do 6 minus 10 to get -4. And then for n, we can do 10 minus 4 to get 6. So I'm going to continue writing this out. So 3 squared, 3 times 3 is 9. Then we have m to the -4th, n to the 6th, over 2 squared, which is 4. It's not pretty yet. We are going to move this m to the -4 to the denominator so we don't have that negative exponent. So next step is just rewriting it 9m, not m, n to the 6th power over 4m to the 4th. And then this is our answer. Yes.
Didn't you do 6 numbers? Oh, wait, you did.
Yeah. Or you could just kind of see that like there's going to be 4 left over on the bottom. So I use the rule where you're supposed to subtract them, and that's what I did. But if you notice, like there's going to be 6 m's up here, 10 on the bottom, there's going to be 4 left on the bottom, like if you were to cancel them out like it did here.
Oh, I see.
So you might not even need to use, like if you can visually see.
Why you didn't put an m next to the 4.
Yeah. Well, because I had kind of put it up there when I subtracted them. Okay. Now number 7. Now we have a negative exponent, but we're still going to follow the same rules and then sort it out at the end. So I'm just going to apply this -3 to all 3 of these guys. So it'll be 2 to the -3, m to the -12, and n to the +6. Okay, then I'm going to put the numbers and variables with a negative exponent on as the denominator, so it'll be n to the 6th over 2 to the 3rd power, m to the 12. And then 2 to the 3rd power would be 2 times 2 times 2, which is 8. So I get n to the 6th over 8m to the 12th power. And I'm done. Okay, and number 8, this is the last problem we're doing like this before we move to the next concept. So for this, we're going to distribute the 2 to everything. So we 2 to the 2nd power, x to the 6th, y to the 8th. Distributing the 3 to everything. negative 3 to the third. Okay, and next step, I'm going to simplify this. 2 squared is going to be 4. Negative 3 to the third power, that would be negative 3 times negative 3 times negative 3, which will be negative 27. So I'm just going to rewrite it as that. So 4x to the 6th power, y to the 8th, I get times negative 27, x to the negative 6, y to the 15. Now I could put this as a denominator and then x to the 6th and x to the negative 6 would cancel, or I could use the rule where you just subtract the exponents. Either way, you're going to get 4x to the 0, then y to the 8th times negative 27, and then y to the 15. X to the 0 is just 1. So we kind of get rid of that because anything times 1 is going to be 1. 4 times negative 27 is negative 108. And then I'm going to combine y to the 8th and y to the 15th to get y to the 23rd power. And that's my final answer. Yes?
Can you show 7 real quick? Just saying.
Oh, yeah. Yeah, let me zoom out for a second. Okay, so now we're going to move to the other page, which is a different skill, but it should be review. It's just kind of bringing it back into our brain. We are going to multiply this. Now, this is considered a monomial because it has one term, and then this would be a binomial with 2 terms. What we have to do is multiply this by everything in the parentheses. We have to distribute it. When we multiply the x times the x squared, it becomes x cubed. So this would be 3x cubed. And then 3x times 7 would be 21x. Whoa. Okay, now for 10. Doing the same thing, now we have to multiply this by all 3 terms. 5x times 3x squared. 5 times 3 is 15, and then x times x squared would be x cubed. 5x times negative 2x would be negative 10x squared. And then 5x times 7x would be 35x. And we just leave it like that. Okay, so that's when you have one term by several terms. You just multiply that by these 2 terms. But what happens when you have 2 terms by 2 terms? You may remember FOIL. If your teacher didn't teach you FOIL, I'm teaching it to you now. FOIL stands for first, outside, inside, last. And it just makes sure that you are multiplying this by both of those terms and multiplying this by both of those terms. So by using FOIL, you just make sure that you don't miss anything. So first means that we're multiplying the first term by the first term in the parentheses. So it'd be x times x would be x squared. And outside means that you're multiplying the outside terms. So 3 times x, the outside terms. So 3 times x would be 3x. Inside is these 2 terms here. So negative 7 times x is negative 7x. And then last would be the last. Negative 7 and 3, which would be negative 21. And then from here, combine like terms if you can, which we can combine 3x and negative 7x to get x squared minus 4x minus 21. Okay. Now number 12, same thing, we're going to use FOIL again. So first would be 3x and negative 2x, which would give us 6x squared. Outside would be 3x and negative 4, so that's negative 12x. Inside would be 5 and negative 2x, which would be negative 10x. And then last is 5 and negative 4, which is negative 20. And then we combine our like terms, so negative 12x and negative 10x will be negative 22x minus 20, and we're done. Oh, I almost forgot the squared. We're done. Do you remember this? I hope. Okay, good. Okay, now what happens when you have a binomial by a trinomial, 3 terms? Same idea, we have to make sure that we're multiplying each of these terms by all 3 of these. So the process for this, there's no like FOIL or acronym to help us remember, but we're going to just take the first term and multiply it by all 3 of these, and then we'll take the second term and multiply it by all 3 of those and then combine like terms. So we're going to do x times x squared, which is x cubed, x times 6x, which is 6x squared, x times negative 3, negative 3x. And then next step is to take the second term, which is 4, and multiply it by all 3 of these. So it'll be 4x squared, 4 times 6x is 24x, and 4 times negative 3 is negative 12. Okay. So now that we have it all written out, we need to combine like terms. There's only one x cubed, so we'll just write that down. Then x squared, we have 6x and 4x, so that's 10x squared. We have negative 3x and 24x. Combined, that would be 21x. And then just one constant of negative 12. Then for 14, we repeat the same process, multiplying this first term by these 3 terms. And then multiplying the second term by those 3 terms. And then combining like terms if you can, which 2x cubed, there's only one with x cubed. But as far as 10x squared and 1x squared, we can combine that. Negative 8x and 5x, that would be negative 3x. And then we just have negative 4 at the end. And we're done. That's it. Okay, so we still have 25 minutes left in class. I have assigned a homework assignment on this. It is 10 questions. It's very straightforward, just like what you saw here. So you can get a laptop, jump on, do the homework. If you finish the homework early, then work on your Khan Academy. Yes. Yes, you may. Thank you for being